Hi, this is a video to explain the lead ID process for a 9-lead dual voltage Y motor. So what we're talking about here is you have one of these motors and there's 9 wires sticking out of it and none of them are labeled and you want to get the thing running. So this is the process to do that. So the first step is to recognize that it is actually a 9-lead dual voltage Y motor, and how we can recognize that is there are 3 groups of 2 leads and 1 group of 3 leads. And how we can find this out is with a continuity test or an ohm meter. And so the next step, once you establish that, is then to draw a diagram of these 3 groups of 2 leads. So here are my 3 groups of 2 leads, and then 1 group of 3 leads. And these are going to be already in the motor permanently tied together. Now the motor I have, I labeled the 9 leads A to I, and what I did is I took an ohm meter and I went from the A wire to the B wire and I measured, and there was no ohmic value showing. It was OL. So then I moved from A to C and I didn't find anything. A to D, I didn't find anything. And finally from A to I, it read a resistance value of about 3.6 ohms. And then I started on the B terminal and measured to C, there was nothing, and D, I got a hit of about 3.6 ohms. And then I started with the C terminal, and I found that the C actually had continuity or ohmic value between C and E, and it was about 7.2 ohms, and C to G. And as a double check, I went E to G also, and it kind of makes sense that these are double the value of these 3 groups of 2, because you're reading the 3.6 here and then 3.6 here, and they're added in series when you measure these. So hopefully that makes sense to you. And then the last 2, F and H, were also 3.6 ohms. And that'll change on the motor. That's just the motor that I was reading. Okay, so step 3, once you label those however you want, the letter method works well, is we want to draw a 9-lead Y schematic. So that's one of these, which you should already know how to label these and recognize what this is. Whoops, there, it's out of sight for you guys. So this is the 9-lead dual voltage Y schematic. And what we're going to do is we're going to label the T7, T8, and T9. So you should already know the NEMA labeling for this. So let's just review this really quickly. So this is T1, this is T4, this is T7, this is T2, T5, T8, T3, T6, and T9. So if that doesn't make any sense, watch another video and just make sure you have those terminals down, because I'll be referring to those terminals for most of these steps. So this step, we're going to label T7, T8, and T9. Now this is the group of 3, and I have these letters as C, E, and G. Now it's up to me to pick what I want as T7, T8, and T9. So I could label these any group and it doesn't matter. So I could label this C, E, or G. So I'm just going to pick C here, and this E, and this T9 is going to be G. So I picked T7 as C. Let's try that again. T7 as C, T8 as E, and T9 as G. Even with this motor, I could have picked this as E, this is C, and so on. But once I pick these do not change. So T7, T8, and T9, whatever wires those are, that's your benchmark, and those won't change for the rest of this process. Okay, so now we have our inner group of 3 labeled, and we're going to go to the next step. So one of the reasons why it doesn't matter, is it's all relative with this process. So we're going to apply a voltage to these and induce a voltage into the other windings, and it's all relative. So I apply a voltage across these two, then what's going to happen is I'm going to get the least amount of voltage induced into this one. So how I label it will work, but it might not be exactly what the manufacturer had it labeled, but it will still run perfectly. Okay, step 4 is we're going to redraw this drawing again. And we're going to keep our labeling. So this is C, this is E, and this is G. And what we're going to do, we're going to apply 15 volts to T8 and T9. So let's just write that on the side here. So apply. Now in our case, T8 and T9 are E and G, or G and E. So let's just say 15 volts applied here. And that has to be AC. Because what's going to happen when we apply 15 volts here, that's our source, to these two windings, it's going to induce a voltage in the rest of these windings. Now for those that have already viewed the delta motor, it's going to be same fundamentals but the opposite outcome. In other words, if I put my pen across here to where I'm applying a voltage to those two terminals, and we stated with the delta that if there was a coil that was parallel with that, that would have the highest induced voltage. And as it becomes less parallel and more perpendicular to the original, there's going to be the less voltage there. So this is the least amount of induced voltage. So if we look at that in relationship of this winding, T1 and T4, to this applied voltage, we'll recognize that this will have the least amount of voltage induced in it. Now these ones aren't totally parallel, but they're not totally perpendicular either. So they'll have a little bit higher voltage. So I already did the measurements here, and I'm just going to draw on the side my 3 groups of 2, and then label them from before. So A and I, B and D, and F and H. So those were my 3 groups of 2. So again, I'm applying a voltage to G and E, and then I'm measuring a voltage across A and I, B and D, and F and H, whatever they are. So when I measured A and I received, or I measured 1.2 volts. And then I measured 2.1 volts across B and D, and 1.8 volts across F and H. So pretty easy to see which one's the lowest voltage, A and I. So because I applied the voltage here, this will be the lowest voltage here because it's perpendicular. Now, I don't know if this is A and I. Oops, if T1 is A or I, or T4 is A or I. But I have to pick something, so I'm just going to say this is A and this is I, and just go with it. I know it's not winding. I just don't know if what the leads are yet. And we have to do a polarity check, and we'll be doing that shortly. But we have to rotate this 120 degrees, but that'll be in the next video. So see you in part 2.